In the question number 36, a man is walking due east. This is due east. This is the velocity of man, due east. Rate of 2 km. The rain appear to him vertically downward at the rate of 2 km per hour. I would repeat this. The rain appear to him, not with respect to the ground, vertically downward at the rate of 2 km per hour. The actual velocity and direction of rainfall with the vertical respectively are. So if I go for the vector diagram, so we'll see. This is the velocity of rain with respect to the man, and this is the velocity of man, and this angle will be 90, right? But if I go for the formula, the velocity of rain with respect to the man is written by velocity of rain minus velocity of man. But I need the velocity of rain, so we should write velocity of rain with respect to the man plus velocity of man. So this is the final equation. So according to this, we can make this vector, and this is the velocity of rain. So if I want to know this angle, this direction, so if this is theta, if I want to calculate tan theta, so we'll write Vm to the Vrm according to the diagram. So Vm, velocity of the man, is 2 km per hour, and velocity of rain with respect to him is also 2 km per hour. So 2 upon 2 is equal to 1. So we will get theta is equal to 45 degree. So we should write here theta is 45, and I need the actual velocity of the rain. So Vr is given by Vrm square plus Vm square, but values are same, so 2 square is here and 2 square is here. So on solving we'll get 2 root 2 kilometer per hour. Kilometer per hour. So this is the actual velocity, and theta is representing the direction. So on behalf of that we can say 2 root 2 kilometer per hour at 45 degree. So my option number 1 is correct. So let's move on, question number 37. If K is the kinetic energy of a projectile fired at an angle 45 at the point of projection, then what is the kinetic energy at the point of landing? And before going to the question, I would repeat that the kinetic energy depends upon only speed. It is not depends on velocity. So if this is angle 45, so this is the horizontal component of velocity, and this is the vertical component of velocity, right? At the point of landing, this is u cos 45, and this is u sin 45. The direction is going to change, but we are going to calculate kinetic energy, so I am not interested the direction of velocity, because kinetic energy depends upon only speed. The resultant velocity will remain same, so speed will remain same. And question says K is kinetic energy of a projectile fired at an 45 at the point of projection. Then what is the kinetic energy at the point of landing? So we can say there is no change in kinetic energy, it will be same. So my option number 3rd is correct. In the question number 38, the maximum height reached by projectile is 4. Maximum height is 4 meter. The horizontal range is 12 meter. Velocity of projection is. So if I go for the relation, because you know if range is n times of height, then if this is my equation number 1, I am going to compare this. So range is 12 meter and height is 4 meter. So first I am going to write height 4. and I need 12 meter because horizontal range is given 12 meters. So we should write here 3, and this is my relation number 2. If I compare 1 and 2, so we'll get n is equal to 3. मुझे ऐसा क्यों करना पड़ रहा है? क्योंकि हम लोग इस क्वेश्चन को सॉल्व कर सकते हैं by using the formula of h, because I need velocity of projection. So you can calculate by h is equal to u square by 2g into 16 n square plus 16 by using this beautiful relation. So now I am going to place the value u square upon 2g into 16, and n is 3, so 3 square is 9 plus 16. So when you will solve this, we'll get, because you keep in mind h is given 4 meters, so you should write here 4. So you could see I need the value of u. So by this expression, when you will solve this expression, we'll get velocity is 5 root g by 2 on solving. My option number 2 is correct. 5 root g by 2. So let's move on. Question number 39. Now I am going to take the question number 39. A ship A is moving westward with a speed of 10 km per hour, and ship B at 100 km south of A is moving northward with a speed of 10 km per hour. The time after which the distance between them becomes shortest is. So first I am going to make the diagram for this, for the given condition. Suppose, as you know, this is east, west, north and south. If I consider the initial point of A is this, so A is moving towards west, this is the velocity of A, and B is moving towards north, so this is B, right? And according to the problem, this distance D is given by 100 km. Okay, and at any time, at any instant, if I join the two instantaneous situation of A and B, so let us consider if I represented by L. So now if I go for the separation of L after time t is given by, so we'll see after time t, if I consider the velocity of B is represented by V1 and velocity for A is represented by V2. So in time t, I want to calculate the separation between these two in time t. So during this time interval, ship B will travel the distance V1 into t, right? So the remaining distance of this is given by d minus V1 into t. So if I go for the calculation of L, so we will use the Pythagoras theorem. So L square is d minus B1 into t whole of square, and second I need this distance. So this can be calculated by V2 in the given time t. So this is the distance traveled by A. So we'll write V2 into t with the square, right? So this is my equation number 1. If I differentiate this equation with respect to the time, then we'll get 2L dl over dt, and when I differentiate this term first with respect to the power, so we'll respect 2 d minus V1 into t, but I need the differentiation this part d minus V1 t also. So when you will differentiate, because you know d is the constant, so we'll get only B1, and the differentiation of time t with respect to t is 1, and the next term is V2 square into t square, so this is plus 2 times of V2 square into t. Okay, but as per the question, if I say L is minimum, so if L is minimum, then according to the maxima minima condition, you can take dl over dt is 0, and if I take 2 as a common in the right hand side, so we'll get 0 on the left hand side, and that is equal minus V1 into D plus V1 square into T plus V2 square into T. When you will multiply it, this minus V1 in this bracket, then you will get minus V1D plus V1 square T plus V2 square T, and as I said, अगर मैं 2 को कॉमन लेता हूँ और राइट से लेफ्ट में ट्रांसफर करता हूँ तो it will becomes 0, right? So now if I take a little bit transfer, so we'll get V1D on the left hand side, and if I take time t as a common, so we'll get V1 square plus V2 square. So if I go for the time, so now I am using this relation, I am writing here. So time t is given by d V1 upon V1 square plus V2 square, and this time is your required. The time after which the distance between them becomes shortest, because as I said, this time, ये जो time हमने calculate किया है उसमें ये condition use की जा रही है कि length is minimum as per the question. So now I am going to place the value. So D, as I said, is 100 and V1 is 10. V1 and V2 10 square and 10 square as per the question. So if I take 100 into 10, and if I take 10 as a common, so we'll get 10 plus 10. This 10 and 10 will cancel out, so we'll get 100 upon 20, and that will give you 5 hours. 5 hours. So on behalf of that we can say my option number 3rd is correct. So let's move on question number 40. So I am going to take the question number 40. The numerical ratio of magnitude of average velocity to the average speed. You know the magnitude of displacement always less or equal to the distance, right? So if I divide by time, it will convert in average velocity and average speed. So on behalf of that, if I use this relation, so we can write magnitude of average velocity less or equal to speed. So if I go for the ratio magnitude of average velocity to the average speed is less or equal to 1. So why this discussion? We can say my option number 4 is correct, equal or less than 1.